Welcome to the Caesar 2 Beginner Tutorial Series. In this first episode, we'll walk you through creating your very first Caesar 2 project. We'll cover how to start a new job, select unit systems, input geometry, material, pressure, and temperature, and most importantly, understand where this data comes from, using real-world engineering documents like P&IDs, line lists, and isometric drawings. Let's begin. Launch Caesar 2 and click File, New, or use the New icon. You'll see the new job name specification window. Give your job a relevant name. For example, Tutorial 1 or Line 101 _ stress model. Make sure piping input is selected. Structural input is used only for finite element structural models. Now select a working folder where Caesar 2 will save all related files. This keeps your files organized for future reviews or modifications. Caesar will show you a summary of the current unit file, called Review Current Units. You can verify conversion constants here, or just click OK to proceed with the default English or metric settings. The main window now shows the classic piping input screen. On the left is the data entry grid. This is where you'll input node numbers, geometry, pipe size, material, and loads. On the right, Caesar will generate a 3D view of your model as you build it. At the top are menus like File, Edit, Options, and Tools, and below them are quick icons for node generation, restraint assignment, and graphics view. Choosing the correct code ensures Caesar 2 uses the right stress equations, allowable limits, temperature derating factors, and SIF libraries. An incorrect code selection may result in underdesign or overdesign, which can be unsafe or unnecessarily expensive. Pro tip: always verify the piping code mentioned in your project's design basis, client specifications, or contract documents. And remember, once you set the code, you must stick to it throughout the entire stress system, unless you're explicitly modeling a code break. In Caesar 2, each pipe segment is defined by a from node and a to node. Example, node 10 to node 20. These help Caesar understand how your piping elements connect. Use logical numbering such as 10, 20, 30, or assign ranges based on branches, like 100, 200, etc. To define direction and length, use the fields dx, dy, and dz, which represent movement along x, y, and z axis. For example, if the pipe runs 6 meters horizontally, input 6,000 in dx for metric, or 236.22 for English units. You'll get this data from the isometric drawing. Now define the pipe diameter and wall thickness, or choose a schedule like SCH40. Caesar can autofill values based on the schedule and material specification. This info comes from pipe diameter, P&ID, line list, isometric schedule thickness, pipe material specification. Other fields include corrosion allowance, example 3 mm or 1/8 inch, fluid density, example kilograms per meter cubed or pounds per cubic foot, insulation thickness and density. You'll find these in corrosion allowance in pipe spec, fluid density in line list, insulation in insulation specification and isometric drawings. Input your project's operating and design temperatures and pressures. You'll see fields like temperature 1, temperature 2, up to 9 temperatures, pressure 1, pressure 2, up to 9 pressures. Get these from line list, P&ID, or process datasheets. Next, select the pipe material such as A106 grade B from Caesar's internal database. This loads modulus of elasticity, thermal expansion coefficient, allowable stress, Poisson's ratio, found in pipe material spec, P&ID, or line list. For global configuration, go to Environment, Special Execution Parameters. Here, you can adjust Borden effect activation, ambient temperature, z-axis direction, wind load factors, FRP settings if using composite pipes, north direction setting. This section is useful for customizing how Caesar interprets the model. You can change your model units by following these steps. From the main Caesar 2 window, go to the top menu and click on Utilities. Now click on Change Model Units. This opens the Input File Units Conversion module. You'll now see 3 fields in the pop-up window. Field 1. Enter the name of the input file to convert. Click Browse and select your Caesar 2 model file. This should be a .a input file you already created. Field 2. Enter the name of the units file to use. Choose either English.fill or metric.fill from the drop-down list, depending on which unit system you want to convert to. Field 3. Enter the name of the output file, optional. If you want to create a copy of the file and keep the original intact, enter a different name or path here. If left blank, the tool will overwrite the existing file. Final note: it's highly recommended to keep a backup of the original model before converting, in case you need to revert. And that's it. You've successfully changed your Caesar 2 model's units. Here's a quick reference guide showing where each input is found and which document governs it. Stop the video and have a look on it. Let's summarize what you've learned. How to create a Caesar 2 job. How to set correct units. How to input all essential values. And where each value comes from using real engineering documents. In the next episode, we'll move to supports and restraints, learning how to add anchors, guides, springs, and boundary conditions. If you found this useful, review our app on Google Play Store, and let's keep exploring Caesar 2 together.